welcome to the second seminar of the series. As you know, the Center for Global Humanities was started in September, officially in September, and the first seminar was led by Ruben Bell. We have an extensive website. The person responsible for that website is sitting right in the back, Neil Gendreau. So every piece of information you'd ever want to know about the center is there, including the broadcasting of this event. Also, I wanted to thank Tom and your wife, Mary. I was incredibly delighted when I saw the letter to the editor that they both wrote, commending the first seminar that they attended in September. So I think it's rather unusual to have a letter to the editor of a major newspaper in the state of Maine commending a course, a university course, a university seminar. So thank you so much for giving us that kind of publicity. And I also want to mention a couple of days ago was a worldwide event known as 350. I don't know, I'm not so sure exactly what that means, but I think it has something to do with some critical level of warning, and so somebody at the university was able to get a movie called Tapped, and they were licensed to make 5 showings of that film. So we still have a couple of showings left for which we are licensed. So if anybody's interested in watching that film in the next week or so, please let me know. I can arrange that kind of event on this campus. There are people watching this event right now from Georgia, the state of Georgia. People are working on issues of water through their church in Haiti. So I want to say hi to Ann Alexander, who's watching us right now. As you know, this is being broadcast live. And I hope you participate with us and ask a question during the course of the seminar. Now I want to introduce the speaker, Tim Ford, who is the Vice President for Research and Dean of Graduate Studies at the University of New England. By the way, we also have, before I continue this, we have a student from USM who has been sent by his professor to attend this event as well. So the goal of the Center for Global Humanities is to reach out to people not in Portland, in the larger Portland area, and hopefully throughout the state. And because we're using the internet and broadcasting this live, maybe if we're someday, maybe throughout the globe, if we can reach those many people. So Tim Ford studied in England. He has a Bachelor's of Science in Biochemistry from the University of Sussex and a PhD in Aquatic Microbiology from the University College of North Wales. After completing a postdoctoral fellowship in the Division of Applied Sciences at Harvard University, he joined the faculty of the Harvard School of Public Health, where he both founded and directed the school's program in water and health. After 17 years at Harvard, he joined the faculty of Montana State University as professor and department head of microbiology. At MSU, he became program director of Montana's NIH-funded IDEA Networks for Biomedical Research Excellence. The program was designed to support projects at 4-year institutions and tribal colleges throughout the state and was focused on both infectious disease and environmental health research. Ford's research interests have included source and drinking water microbiology, microbial cycling and transformation of pollutants, biofilm microbiology, microbiologically influenced deterioration of materials, and microbial populations as biomarkers of environmental stress. He has both directed and participated in water quality related projects in the US, Canada and the UK, Mexico, India, Russia, and the Philippines. And he is currently building collaborations with colleagues in Hong Kong and China. He is widely published in water and public health related fields and was the 2006 recipient of the GenProbe Joseph Award for exemplary leadership and service in the field of public health. He has recently been awarded a concurrent professorship at Nanjing University in China His current work in environmental health is focused on exposure assessment to both chemical and microbiological contaminants on American Indian reservations in Montana, where he continues to advise 2 doctoral students. In addition to a number of international initiatives, he anticipates developing new research areas on rural health in northern New England. So I present to you Tim Ford. Thank you.
Let me just clip this on. Anwar, thank you very much for that introduction. Can everybody hear me okay at the back? It really is an honor to be part of this seminar series, and it's actually my first talk at the University of New England. Even though I've been here for a year and a half, I've given numerous talks in China and none in Maine. So this is really nice to be here. And you know, I don't normally give humanities talks. I'm a microbiologist. There's always a detail, isn't there? Is that better? Well, let me start with one of my props, which I'll come back to at the end of the seminar, and also useful to make sure that my voice holds out. Again, as a microbiologist, I don't have the humanist skills to be able to just give a talk without slides. So tonight, you will get a PowerPoint presentation, but do please feel free if at any point I start to wax microbiologically, stop me and we can talk in more general terms. I've tried to remove all the references to specific pathogens, with the exception of cholera, which is an important one, as we go along. As I did a little research for this talk, I came across this rather good paper on water symbolism and culture. And I'll need my glasses to just read a couple of points from it so that I can at least pretend to be of the humanities. This is by Mohamed Labi Bouguera, who's, and this is, by the way, you'll have to excuse this is going to be British French. Le rapport de l'Institut Viola Environnement. So that may sound a little different from the French you probably learnt in school. And I just want to give you a couple of quotes from this. Few elements have influenced the symbolic, ritual, and metaphysical values of mankind as much as water. It is deeply rooted in a highly emblematic manner in our cultural traditions, for culture is nothing more than man's perception of his natural environment. So how does water affect culture? Well, we're very familiar with water being used in numerous religious texts. It's referred to in many different ways: holy, purifying, baptismal. Many other words are used to describe water. In the Quran, water is the key element of creation, is referred to so frequently, 63 times. Some speak of the holy book's obsession or bewitchment with water. But again, quoting from this wonderful paper, in Arab culture there's nothing surprising in the immense interest in water revealed in the sacred writings. In his famous essay on water in Islamic thinking and Arab literature, Professor Muhammad bin Abdulaziz writes, "It will suffice to say that Arabs are so passionate about water and place, so much hope in its coming, that they have rightly come to be called sons of the water of heaven. Among Arab Muslims, the best you can wish for someone from whom you are seeking a favor is God give you water. Thinking of days when all is harmony and peace, when the soul finds serenity, they will describe such days as Maska Allah, watered by God." Now, I found it particularly interesting to read also from this article that for certain historians, the annual flooding of the Nile acted as a catalyst, or at least paved the way for the emergence of writing, geometry, and arithmetic. Quoting Mahmud Hussein, he states, "Writing, like geometry in ancient Egypt, came into being when the population settled. While people dwelt in the Sahara, no one took the trouble to note down anything. There was space enough and to spare. But when the process of desertification began, people flocked to the Nile Valley. Population density increased and organization was required to keep track of who was living where. Demarcation introduced the idea of computation, writing and drawing in order to keep records of ownership. I found all of that very, very interesting, and clearly, from my perspective, as someone who's worked in water and health for all his career, the microbiological aspects of water and health, water clearly is the beginning of everything, whether it's scientific or whether it's humanities. Again, that may be a slightly biased perspective. I'm going to move this on to, let's see, I'm going to need the keyboard here, to the PowerPoint. The book, by the way, The Blue Death, can I ask how many people have actually had a chance to read the book? Well, quite a few of you. That's terrific. I think it's well written, a little sensationalist in parts, and I think perhaps Bob Morris may have taken a few extreme perspectives on describing various aspects of the cholera story, the Milwaukee event, the Walkerton, Ontario event, some of the events that I'll touch on briefly in my talk. But my talk's going to be a little bit broader than the book, and we can hopefully come back to aspects of that of the book in the question period. Now, oops. Oh, this is my attempt at technology. I think, could we have the lights down just a little bit? And this is simply a title slide which puts water in perspective from a planetary scale. Most of our planet is covered in water. Now again, you know, the humanities and the science connection. Now this was somewhat fortuitous. I was actually meeting with one of the candidates for the position of chair of the art department the other week. And I said I was going to give this talk on culture, society, and water. And he said, oh, of course, you're going to mention Leonardo da Vinci. My immediate reaction was, not who. I did know who Leonardo was, but I didn't know his connection with water. Let's see if this pointer works. This may or may not be a self-portrait, but in a way, it turns out he's actually sort of doing a little research on the internet, the father of hydraulics, and he did these wonderful drawings of the flow of water around objects, from which he came up with a number of designs for in hydraulic engineering that I'm sure some of you are probably far more familiar than I am with Da Vinci's work here. Now what I want to do, and I'll keep an eye on time here, is just give you a few facts, talk a little bit about disease and culture, how disease really has framed culture through the years, talk briefly on John Snow and cholera, since that's a key component of the book, and cholera has affected the way our cultures have developed in the past and frames our cultures today in many developing nations. I'll talk specifically about India because I've had a number of research projects there and try and be very light on the research part and be more descriptive. Talk about this concept that I actually came up with this past spring when I gave a talk on Asia and the environment, the concept of sanitary imperialism. Briefly discussed the developed world, which is the greater focus in Bob Morris's book. Bob, by the way, was a colleague of mine when I was at Harvard. He was at Tufts University, and we collaborated on a number of projects together. The Blue Death is the book that I actually wanted to write but never had time, and then he came out with it first. So I now want to do a book on sanitary imperialism. Again, whether I'll ever have time, I'm not sure. And then hopefully we can have some lively discussion. So a few facts, if I can stabilize this. As I showed you, the planet is primarily water. The surface of the planet, primarily water. Only about 3%, and the actual numbers vary depending on what source you go to. 3% is actually fresh water, and a very small fraction of that fresh water is actually available to humans, i.e. surface water. The rest is tied up in glaciers and in deep groundwater that we don't have access to. Much of the global population will face water stress and water scarcity, and these are defined terms in the water field by 2050. 3 million will die from waterborne disease per year. That's a figure that is reported by the World Health Organization from time to time. And again, it's very much guesswork. Even greater guesswork is 4 billion cases of diarrhea per year. How do we know that? I mean, we have no real idea. I mean, if I was to ask this audience, how many times have you had diarrhea over this last year? I suspect I would not get a very definitive answer. Water is actually, a number of people sort of link water to about 80% of all infectious diseases worldwide. When you think about it, some of the real killers like malaria, they're dependent on a vector, the mosquito vector, which is in itself dependent on the presence of standing water. And we look at most tropical diseases. They have some vector or other that depends on the presence or absence of water to grow and hence transmit disease. And of course, water is also a major cause of international conflict. I'm not going to go into that in any real detail today. I mean, we can all point to occurrences that have happened, conflicts that have happened globally that have a water connection. These are some of the hot spots, but when you think about it, half of the world's surface area is shared watersheds. So half of the countries throughout the world share their watersheds with another country. And what you do to the upstream environment dramatically affects what happens downstream. And that has resulted in a number of these hotspots I'm sure we're all familiar with. You could also look at the America and Mexico. The Rio Grande is another hotspot. In California, the use of the Colorado River is a hotspot. Now, water, of course we're intimately associated with water. Our bodies are we're approximately 70% water, close to 80% when we're born, gets a bit lower as we get older, 60% or a little bit less. And we have a lot of household uses of water which are absolutely dependent. In particular, we tend to think of water ingestion, drinking water. It's worth noting that drinking water, particularly in developed countries, is a very, very minor component of our water use. If you, I'm sorry this is a busy slide, but it sort of depicts all the sort of household uses of water. And you could look through those all the way from use of a washing machine to washing the car. Each of these activities use a large amount of water, and less than 0.2%, this again varies a lot depending on the source you're looking at. This, I believe, was the National Resources Defense Council data from back in the 1990s. Less than 0.2% is actually used for ingestion. Now this actually has huge ramifications in terms of treating our drinking water. Do we really need to treat to potable standards, to drinkable standards, this volume of water when we actually only ingest such a tiny fraction of what's present there? I can do that. Now this painting by Bruegel, The Triumph of Death, represents to me the total failure of public health. It's also a wonderful, wonderful depiction of the type. Sorry, I almost pointed the laser at people. I should know enough not to do that these days. It's a wonderful depiction of the kind of art that came out of the plague years in the 1400s and 1600s, major periods of the plague throughout Europe, throughout the UK, really stimulated this kind of art of death and destruction. 1350, the Black Death, basically the plague, a disease caused by a bacteria that's transmitted by a flea that feeds on the black rats that were prominent throughout European and English cities as well. 50% of London's population are thought to have been killed in 1350 by the Black Death. At least one source attributes a social upheaval to essentially be the end, contribute to the end of the Middle Ages. In 1665, the Great Plague of London. I'm just focusing on London here. I'm not British-centric. I'm now a real American citizen, so I don't have to be anymore. And I'll talk about Philadelphia later on, and Milwaukee. But these are two of the facts, or the Great Plague events that we can point to as really changing and structuring society. And of course, You know, the plague is not directly a waterborne disease, but it's a disease that's exacerbated by poor sanitary conditions, poor hygienic conditions, and is related to the whole failing infrastructure of these societies at the time. Now this is, again, these are more plague pictures. This is a wonderful depiction of the Dance of Death, the Dance Macabre. This is Notke's original Dance of Death in St. Mary's Church in Lubeck. Unfortunately, this was destroyed in 1942 during the Second World War. And this is a replacement, and there are actually a number. This is just a small portion of Alfred Marlowe's replacement. This is the stained glass window. Within a number of the old English churches and cathedrals, there are stained glass windows that also depict the kind of death and destruction that has been caused by major disease events. So here are just a few, again, rather small writing, I'm afraid. These are events related to water that have affected cultures in a major way, societies in a major way. Yellow fever, 10% of Philadelphia's population died as a result of yellow fever in 1992. Between 92 and 99, yellow fever is a pathogen, a viral pathogen, transmitted by mosquitoes that depend on collection of water in small areas, tree stumps, places like that. Today, in tires that are left out, they'll grow mosquitoes that could potentially transmit yellow fever. 1805 to 1807, typhus and dysentery are partly responsible for destruction of Napoleon's army. 1870 to 1823, the cholera outbreaks throughout the 1800s were absolutely devastating throughout Europe and Asia as well. Again, 1826 to 1837, and another yellow fever event, this time in the early 1900s in New Orleans, with 4,000 people sickened and 500 deaths. Now, just as the plague affected art and literature as well, so did cholera. This is a typical picture from the time, people carrying out the dead. This is Exeter, which is very close to where my family lived down in Devon. Exeter in 1832, Goldsmith Street, they're removing a cholera victim. And this wonderful picture is by this cartoonist, Toma Hanuka, who gave me permission to actually show this picture that he did fairly recently for a Stanford Magazine article, focused on cholera's emergence and the etiology of this disease. It turns out that cholera, or rather the organism that causes cholera, this bacterium, Vibrio cholerae, and that's probably the only bacterial name I'll give tonight, is associated with plankton. And so this is cholera emerging from the oceans, which literally is what it seems to do. When we have global warming trends, increasing sea surface temperature, increasing ocean plankton blooms, we anticipate increasing cholera epidemics and pandemics, particularly in countries like Bangladesh. So literally it does seem to be almost rising from the ocean. Now, you can correct me completely on this one because I'm way out of my league. And this again is just searching for information on the root of these two words. Root of the word culture is colère, the old French root of cholera is colère. Now, perhaps one of you could tell me if there are any etymological links. I suspect not. I don't know what the potential linkage is between French and, French and Latin. Is there a linkage there?
French and Latin, yes.
Splendid. I hope there might be. I hope there wasn't completely, what is it you say in this country? Off third base or something? Or off?
Off the wall.
Off the wall, okay. Now cholera, in terms of the cholera story, the one person that we really look to for having provided the information we know today about the disease cholera is John Snow. And Bob Morris spends a lot of time in his book talking about John Snow. And John Snow is the hero to anybody in epidemiology. My field of water and health is closely related to epidemiology as well. I do a lot of work on making the connection between exposure to waterborne disease and health problems. John Snow in the 1800s was the first person to make the link between drinking sewage from the Thames River and getting cholera. And so this is actually the first acknowledged epidemiological study. He also came up with the theory that if you ingested contaminated water, it would pass through the system and would be excreted out in your what are called rice water stools. Tell me to move if I'm standing in anyone's way, by the way. So the human ingests the pathogen, the bacterial pathogen, goes through the body, results in symptoms of cholera, is discharged in these stools and in vomit, and it then contaminates the drinking water again and is also transmitted from hand to mouth. At the time, the thought was that this was something to do with bad quality air. That was how you contacted cholera. So this was a real breakthrough, discovering the root of cholera infection. He also did this extraordinarily elegant piece of epidemiology by being able to link the tap water in a particular area served by a particular company, in this case the Southwark and Vauxhall Water Company. There were two major companies. This is the Thames River, by the way. This is sort of the London area. South of the river is served by two companies, Southwark and Vauxhall and Lambeth. The Lambeth Company took their water from about 10 miles upstream of the City of London, whereas Southwark and Vauxhall took their water almost right in the center, or within sort of a mile or half a mile of raw sewage discharge into the Thames River. And what he found was that in areas that were served by both water companies, about half the number of cholera deaths occurred in a given time period. In areas just served by the Lambeth Company, there were no cholera deaths. So he made that link, that the water was a major source of cholera infection. And the anecdotal story is he then went and removed the handle from the Broad Street pump. It's a little more complicated than that. But as a result of his work, the handle was removed from the pump, and this is probably not the original pump. But he was able to pinpoint within a given area the primary source of cholera for a particular part of the city. By disabling the pump, he was able to dramatically reduce cholera. Now, there's some sort of confounding issues in there too, but this really was the first instance of an effective epidemiological study. Now, back to the relation between populations, cultures, societies, and water. Here's a NASA image from space of the light on Earth. Obviously, there's some areas where, for socioeconomic reasons, you don't see anything close to the amount of light coming from specific cities or towns, etc. But if you look closely, you see that along coastlines and along rivers are where most of the lights occur. And water is always the focal point for societies to establish themselves. This is a close-up of, this is India, this is China, and if we move on one and look at two river systems, and I focus on these two river systems because they're areas that I conduct research. In India, you've got numerous major cities along the Ganges River, from cities like Delhi with about 18 million people down to Calcutta with about 16 million. In China, on the Yangtze River, cities like, or municipalities like Chongqing with 30 million people. Remember, Maine has, about 1 million people, to put it in perspective. So about 30 million people in the Chongqing area, and down in Shanghai, over 20 million people. So vast, vast populations living by these river systems and dependent on these river systems for their social, economic, and religious development as well. Now, I want to very briefly touch on some of the water quality studies that my group has conducted in India, both in Hyderabad and in Varanasi. This is the city of Hyderabad. Again, very densely populated city. Water is, of course, extremely important to the culture, to the society of Hyderabad. It's used extensively as a drinking water source. It's used for cooking, used for washing here on the streets. These are all aspects of the culture, particularly of the slum cultures, the need to wash in the drains by the streets. Here is a drinking water pump in a slum area of Hyderabad. Now, this is this is a major issue in a city like Hyderabad because the slum areas are supplied by water at the end of the distribution systems. And Hyderabad has about 2 hours of water supply in their distribution system per day. That means that for 22 hours of the day, the distribution system lies stagnant. And I'll come back to that at the end of my presentation, but that's a real problem in terms of contamination of the drinking water source. Now, this is a bit of a busy slide, but what it illustrates is the burden of disease in relation to the socioeconomic status of a population. This is increasing socioeconomic status in Hyderabad. These are a variety of different waterborne diseases, and this is the rate per 1,000 population over a 2-month period of disease incidence. And as you would expect, disease is dramatically higher if you live in those slum areas down by the river systems, which for most of the year are essentially raw sewage. Some of the risk factors that we've measured for exposure to waterborne disease in Hyderabad are ones that you would expect as potential problems. Sewage around the home is perhaps the biggest risk factor. Lack of education is a huge risk factor. And frankly, without education, no intervention approach to trying to reduce exposure to waterborne pathogens is effective. And deteriorating infrastructure is also a risk factor. Cleaning utensils directly on the road, again, a forced part of the culture perhaps is a risk factor for infectious disease, use of damaged food, drinking water without residual chlorine, using mud as a cleaning agent. All of these, as you might anticipate, expose people in these environments, in these cultures, to greater levels of infectious agents. The other study we've done in Varanasi, which is, would be an ongoing study if we got additional funding, which we're still working at. You know, the Ganges River has been so important to Indian society, particularly to the Hindu faith, as a purification, the way to purify your sins. If you immerse yourself in the Ganges River, then it purifies your sins. Disposing of dead bodies in the river is the only way to get to heaven. Essentially, so there's a specific term I wrote down for that. They actually call it the world of the ancestors. And a phrase from the Mahabharata is very telling. If only the bone of a person should touch the water of the Ganges, that person shall dwell honored in heaven. So the Ganges is extraordinarily important to culture, and that feeds back again into how we intervene to reduce the burden of infectious diseases. In Varanasi, sewage treatment is inadequate, dramatically inadequate, as it is in many other Indian cities as well. Much of it is discharged to the Ganges River as the river flows through the city. I love this picture, the juxtaposition of this beautiful scene by the Mother Ganges and the reality of many of the people that live in Varanasi in terms of the conditions under which they're using that water resource. Actually, this picture is quite telling. These children report that often when they take drinking water from the pump, it's full of small worms. Now, these are probably intestinal nematodes that are a result of connection between the water that's being drawn up by the standpipe and the Ganges itself, or a wastewater collection system. There's tremendous use of the Ganges. There's daily washing, there's ritual drinking of the water. There is, in the mornings, people go into the Ganges to pray and to face the rising sun. There's daily washing and bathing shown here. Steve Hamner, by the way, is my research scientist. He's still out in Montana State University, but he's also a great photographer. So most of these shots are from Steve. There's individual and commercial washing, laundromats on the Ghats in Varanasi. There's ferrying and fishing activity. The key issue, though, is that whatever the exposure to the river, it's very much a shared resource. The animals bathe throughout the river. Obviously, there is disposal of the dead in the river too. This is actually a dead fish, this man washing nearby. This is a dead cow floating down the Ganges. Again, this man is washing right next to him, next to the corpse. This is Steve. I just wanted to introduce you to him since he'd taken these pictures. He is doing something that no microbiologist should ever do. He is sampling the river Ganges without a glove. And he came back to Bozeman, Montana, and was ill for about 2 months. Now, I've no idea whether it was this particular exposure or something he ate in the city, but it's a reflection of how you have to be very careful. And this summarizes a large amount of data on the work that we've done in Varanasi. As you go through the city, and this is upstream to a downstream site, as you go through the city, you see an increase in red. I've got AGI. That stands for acute gastrointestinal infections of unknown etiology. We've no idea what the causative agent is, what's making people sick. But what you see as you get down to the more slum areas, an increase or the emergence of cholera cases, 8% and then 14% in the slum area downstream of the city. This data is obtained through questionnaire surveys. It's on no official database. All policy decisions in Indian cities as elsewhere are made on hospital databases that are not maintained in cities like Varanasi. They're not maintained in American cities either. 14% of cholera cases with a 50% mortality. So a large number of the homes we surveyed in this particular area had particularly children that had died of cholera and are given back to the river Ganges. So the information we obtain with these kind of water quality studies is useful in getting decision makers to try and put in place improved wastewater treatment. And that's really the focus of that side of the work. There's a whole other side of the work in relation to emergence of new diseases which can occur in these types of environments. And I won't get into detail today. The education of the people really requires a cultural shift. If you look, again, at the Ganges, it literally is the lifeline of Indian culture. And we approach these types of studies from a very sort of uncultural perspective, a very top-down perspective. And in that vein, I'd like to introduce you. Wait a minute. Nope, it's just slightly out of order, but that's fine. Despite the level of disease in the Indian cities that I visited, you don't see people who are unhappy. If you look at these kids, and this is a wealthier part of Varanasi, smiling school kids, but even in the slum areas, you don't see people unhappy, dejected by the fact that they've got cases of cholera, dysentery, malaria. The biggest complaint of women in these slum dwellings was they couldn't sleep at night because of mosquito bites, not because they had cholera in the family. And here, even the little boy that I showed earlier, flying his kite in the River Musi, this is from Hyderabad, is smiling. He's happy in this environment. We tend to have, as I say, this top-down approach to water studies. So this is a slide I thought we were coming to. This is someone I want to introduce you to. This is Reginald Crawford Sterndale, and he wrote about municipal work in India, particularly focused on sanitation, general conservancy, and improvement in municipalities, towns, and villages. Now, Reginald happens to be my great-great-grandfather, so I have a very strong personal connection to Reginald. And he wrote some fairly disgraceful things at the time, which was absolutely typical of the British attitude back then, and I hope is not typical of the British attitude today. No sanitary arrangements will work satisfactorily in this country unless there is constant and careful supervision in every department, and this can hardly be secured without European or Eurasian agency, and I think he would have preferred to say British here, in the supervisors, inspectors, and overseers grades. Unfortunately, it does continue today. This idea of sanitary imperialism, this top-down approach to providing clean drinking water or wastewater removal. And I've seen many examples, World Bank funded examples, World Health Organization, USAID examples, installing latrines that are never used because they're dark, smelly, and they may charge a rupee or two. People don't want to use them. Focus on drinking water when the bigger problem is actually getting rid of wastewater around homes. Recommend treatment that can never be maintained, and we've come across that in cities in Russia, where ozonation has been recommended without any maintenance to either install or train people on how to use ozonation. Mainly suggesting behavioral changes that are culturally unacceptable. You know, we can't tell people in Varanasi, no, you can't go into the Ganges and pray because it exposes you to all these pathogens. There have to be cultural alternatives. I love this photograph that I took actually in Hyderabad a few years back. Your health, your choice. If you worked in India, you realize there is absolutely no choice whatsoever. We may complain about health in this country, but in India, you can completely forget the issue of choice. So briefly, what about the developed world? You know, we saw, this is Philadelphia, back in, you know, from 1885 to 1945, after John Snow's work on cholera, after our discovery of the fact that infectious diseases in water caused a wide range of diseases, we began to introduce water treatment. That was extraordinarily effective. Filtration in 1906, these are cases of typhoid in Philadelphia. Dramatic decrease in filtration, and then again, dramatic decrease in chlorination. This has led to a complacency in developed countries. This is you know, I'm not going to read through this, but very briefly, this just tells you that even in this country, if you're on surface water, you're almost certainly downstream of treated sewage discharge, which in dry periods, the drinking water that's being treated from surface water can be 100% of treated, you hope, treated sewage just upstream from you. Now, unfortunately, our groundwater is also beginning to look the same. We're finding so many different chemicals. There's no groundwater sample, I would contend, in the United States that does not have some trace of a contaminant chemical. So that we really are looking at a need to very carefully treat our source waters as well as protect them. We had a wake-up call, a major wake-up call, back in 1993 in Milwaukee. These are people lining up to a stand pump, not something you often see in an American city. This is because of an outbreak of cryptosporidiosis, a disease we'd not seen globally. We've not seen globally up until this point. It's only in the 1970s we began to recognize that this pathogen existed. This was the largest waterborne disease outbreak ever to occur in the United States, and it was from contaminated water getting into a treatment plant we think was somewhat inefficient in the way the filtration was operated. Very, very resistant pathogen. This may be a slight exaggeration, probably more like 60 related deaths. But over 400,000 people were sickened with extreme economic consequences, as you can probably imagine. As I have to throw in a little microbiology, this is a picture of Cryptosporidium parvum, the organism that causes cryptosporidiosis. It's one you should all know, since it is the most common cause of waterborne disease in the developed world today. The other event happened in Canada, in Walkerton, Ontario, and this was E. coli 0157 in drinking water. That's the bacterium that caused the hamburger outbreak that killed a number of people. This occurred in Walkerton in 2000. It's basically, this is the timeline, but 7 kids were killed. 7 people were killed as a result of exposure to this pathogen in their drinking water, and this was due to poor operation. There's sort of anecdotal evidence that the water treatment operator didn't like the taste of chlorine in his drinking water, so didn't chlorinate. And when he measured indicator bacteria in the well water, he didn't report it because he didn't think it was worth reporting. And a lot of this has come about because of flooding combined with intense agricultural practices, putting animal husbandry in this kind of density, these confined animal feeding operations, resulting in a lot of runoff of pathogens whenever flooding occurs. 5 minutes? Okay. what we're missing here is this whole hydrologic cycle. And I'm not going to go through any of these numbers, but essentially what we don't seem to have understood is that whatever we put in our water, in our source waters, in our groundwater, ends up either in our oceans. Contaminants can then be aerosolized or can precipitate back into the oceans. It's all a continuing cycle. And that's all I'm going to say about the water cycle. We can talk about it more in terms of during the discussion time. So we don't understand the water cycle that results in every time we put out wastewater, there's a route to which we can be re-exposed. The other key issue we have in developed countries is what's under our cities. This is Boston's distribution system. There are literally thousands of miles of pipeline under our cities distributing water to everyone's homes, businesses, etc. This map only shows the major trunk lines, doesn't show the myriad of individual connections to people's houses. Now, some of this distribution system was laid down 100 years ago, more than 100 years ago. I've been saying 100 years for, gosh, close to the last 20 years. So maybe it's 120 years now. Some of Boston's system is still thought to run through hollowed out logs. Now, the way we used to put down a distribution system, well, the easiest way was not to build two ditches, but to build a ditch that collected wastewater and run our distribution pipes through that ditch. So whenever there's a failure of a water pipe, there is a very real possibility that we will suck wastewater back into the drinking water system. This is, we estimate about a 20-year-old pipe. And I have far worse pictures showing the pipe completely blocked. But it doesn't take very long for water to corrode steel pipe. And these conglomerations, tubercles they're actually called, are the result of chemical reactions that oxidize the surface of the metal, and biological, microbiological reactions too, they're actually microbes that eat their way through the walls of a steel pipe. And these little pits around this pipe are probably the result of a particular type of bacteria. It's called a sulfate-reducing bacteria that literally eats metal. And so our distribution systems, shown here, are huge sieves of water. Now, if water is all about flow and energy, and my wife used to be a feng shui consultant. Feng is wind and shui is water. And the Chinese think that society should flow like a river. What is this doing to us under our cities? That we've got this constant flow of water leaking out throughout the distribution system. What we do in this country is we push water through at a very high pressure in order to deliver sufficient amount of water to the consumer, but also to prevent back siphonage of contaminated water from the outside. If we drop the pressure in this pipe, it'll suck contaminated water back into the drinking water supply. So we push water through at a tremendous pressure. We probably waste about 40%. So 40% of all the water that we're treating at the treatment plant that goes into this distribution system flows out of these pinholes, out of these sieves. Now, from an energy point of view, from a feng shui point of view, not my area of expertise at all, it's very interesting to think of these flows going on constantly underneath our cities. Bob Morris and myself were very focused on this whole area back in the 1990s. This is a Boston Globe article we did in 1998 following a huge debate in Boston about what we should do in terms of protecting our water supplies, the kind of water treatment that was needed for the city. And we were arguing that we have to have this multiple approach, this multi-level approach, whereby we also looked very seriously at upgrading our distribution systems. And it was an intriguing debate. We actually lost the debate here. They didn't put in water filtration in Boston at the time, and the downstream health ramifications I'm not sure about. But unless we're able to completely look holistically at our water treatment, our water source protection, and how we distribute it to the population, we're not going to be fully protective of human health. So what do we do? Well, back to my prop. We all seem to turn to bottled water. Now, I asked at the beginning, is water a human right? Is it a basic human right? And that's something you hear from a lot of people, that water is a basic human right. But, you know, realistically, is this the human right? Is it a human right to spend all the money, the millions of barrels of oil to produce these bottles, the amount of waste that's created? And you look on the internet, it's all over the place, but it's, you know, millions of tons of waste from these bottles that then contaminate the environment. I've seen figures from 70 to 90% ends up in landfills, does not get recycled. Probably this cost me far more than a glass of milk. It's sort of 3 times approximately the price of the equivalent volume of gasoline. So there are ramifications to our drinking water. There's also the whole issue that if we consider that water, clean water, is a basic human right, we've also got to look at what are our other basic human rights. Is clean air a basic human right? Access to clean food, are these basic human rights? I think the fact that as a society we've moved towards drinking water, and this, of course, this isn't the United States, this is a meeting in China. Now this is, what are they now? They're 1.3 billion people. Meetings in India, the same thing. Bottled water at all these types of meetings, 1.1 million in India. The global use of bottled water is extraordinary now. But the price of this bottle is not something that anybody in that slum I showed you can afford. It's barely something that people in lower income groups in this country can afford, frankly, as a stable resource for drinking. So let me leave that and move to discussion. There is one little statement I'd like to read here from that Water Symbolism and Culture paper, that water is not just a resource, it is a key issue of civilization. The gulf that the industrial era has created between us and this vital element must be bridged as a matter of urgency. That was Domenico Luciano, who's the president of the International Water Civilization Center. So with that, I'd like to leave this and open it up to discussion. I finished with this slide of the Yangtze River, even though I haven't talked about China issues, water issues in China. It's the area I'm beginning to focus some of my own research interests. So thank you for listening, thank you for attending, and particularly the person in Georgia hopefully has been able to last out the talk, and we'll have some questions. So I would welcome any discussion. Well, how's the question because you didn't have a microphone. The question was, what about water from Sebago Lake? You know, I've only been, here's my excuse, I've only been in Maine for the past almost a year and a half, but I wouldn't drink it. I imagine it's a little bit cleaner than some of the other surface waters further south of us. Sebago's the one inland from Portland, right? Yeah. With Giardia, Cryptosporidium, and the amount of human activity around the lake, there's certainly a risk of giardiasis. There's probably a risk of more severe infections from some of the other pathogens, like E. coli 0157 that I mentioned. You know, so much depends on your own personal immune system as to what you can take. We're all subject to very different infectious doses, so that, you know, the very young, elderly, immunocompromised, pregnant women in particular, are extraordinarily susceptible to contaminants. I would say 10, 15 years ago, I'd probably have canoed on Sebago Lake and drunk the water. Now I don't think I would, because of the amount of development in the area. But you probably know more about the development than I do. There's a lake that might be comparable, that I'm more familiar with, Flathead Lake, on the Flathead Reservation in Montana. There, you know, that's a relatively pristine lake, but I wouldn't drink that water directly without treatment. And the tribe, the Salish Kootenai tribe that I work with out there, treat that water source simply because there is a lot of tourist activity, recreational activity around that lake, a lot of animal activity too, and we're finding high levels of fecal indicators in that water. I'm sure they're present in Sebago too.
Hey, I was worried about a lot of things before this talk. Now I'm worried about more. But let me just ask you this. You talk about the development. How concerned should we be about the use of herbicides and pesticides on people's lawns? That I can walk into Lowe's and walk out with tons of toxic materials to put on my lawn to keep it either greener or dandelion free or grub free. Is this something we should be concerned about?
It's something that concerns me on a personal level considerably because of the link between many of these chemicals and health outcomes, including cancer. The issue really is, there are obviously many issues in relation to using chemicals on the regenerative capabilities of the soil, but if those chemicals are getting down into the groundwater supply or running off, and probably more of a problem in most areas is running off into surface waters. We've established the Center for Land Sea Interactions here at the University of New England. And one of the areas that we want to focus on is what are the fate of some of these chemicals that are discharged in the watershed to the Saco River. What effect are those chemicals eventually having on the marine mammal populations in the coastal areas? Whether they're accumulating in some of the commercially important species, whether people are then exposed as a result of consumption of those species. So that's an area of great interest. I now live by a golf course, and we have a little pond at the bottom of the garden that I know has probably been receiving a lot of runoff from that golf course. And I'm going to be very interested it's full of bullfrogs, by the way. So I'm going to be interested to do a study on those frogs, see if they're coming up with two heads or multiple legs. But seriously, there are concerns about the amount of chemicals we use for our lawns, for our golf courses, simply to create a green, sort of verdant environment that, if we're then exposed through the drinking water, can result in a number of different health outcomes. Now, they're very hard to remove. There's an argument in Bob Morris's book, by the way, that if we have point-of-use filtration in the home, we can use something like a charcoal filter, activated carbon, to remove some of these organic contaminants that are not routinely removed through water treatment. If you're on well water, as we are, in fact, my house home in Montana was as well, unless you're on deep aquifer water, then there is a good chance you could be exposed to higher concentrations of those chemicals. And I speak back to my work on the Crow Reservation in Montana, in that many people in that community have very shallow wells. And so they're essentially drawing water from what's called groundwater under the influence of surface water. And it's an agricultural area with a lot of use of chemicals in the agricultural practices there. So we know that a lot of those chemicals are actually seeping down into the drinking water.
Fascinating. It seems to me, for basic Malthusian reasons, that the population continues to grow. This is a losing battle. Human populations always contaminate their environments. It's part of our success. And so the more of us there are, the more difficult this will be. And I guess we could look at it in a more positive light. The better it will be for the bacteria that parasitize us. Is there a discussion of population limitation in connection with these water issues?
There is. The whole issue of water scarcity is a population issue. It's both a population and a pollution issue, in that we're getting diminishing resources and more contaminated resources. So they do come hand in hand. And a lot of people will talk to you about water quantity being a far more important issue than water quality. And in theory, we have the technologies to clean up any level of contamination. And the space station is an example. They recycle literally everything except for fecal material on the space station. The technology is there to clean it up. With nanofiltration technologies, we literally can have what we consider to be safe water, safe drinking water, but at a huge expense. So much of our technology is unaffordable at least for most of the developing world. So that is very much part of the discussion. Part of the discussion is that as population increases, more and more people move to the coastlines, move along rivers, congregate near water sources and increase that level of contamination. And of course, people move to the most ridiculous places like Los Angeles. You know, you should not live in an arid environment that does not have a natural water source. And the expense that, I see Jenny laughing, she's got connections out there, right? By the way, I guess I should have, oh, you have the microphone, so the audience would have heard the question. So yeah, quantity is a huge issue.
Because of the controversies regarding chlorination, both in terms of its toxicity and the development of organism resistance, you briefly spoke about nanofilters, but what are your comments about either point-of-use filters or the communities acquiring major filtering systems for their water supplies? I know it's expensive, but is that something that being addressed at some point?
You know, in some cases that might be the ideal solution. A lot of, at least a lot of the more wealthy homeowners in cities in India do have point-of-use types of filters, ceramic filters, sometimes with a bactericidal agent associated with that filter. Silver is often used, colloidal silver. There's pros and cons about point-of-use filtration. With point-of-use filtration, you're relying on the homeowner to maintain that filter. And if it's not properly maintained, then it's a wonderful growth medium for bacteria. So if you're not changing out those cartridges on a regular basis, there's a very good chance you'll grow these films of microorganisms which can contain a lot of different pathogens. You know, on a point-of-use basis, it's going to be very hard, I think, to regulate the standard of water that comes out of those filters. On a building scale, you know, we worked for a while in Russia, in the city of Cherepovets, where they have these high-rise apartment buildings that are very uniform and lend themselves, multiple families in these apartment buildings, lend themselves to a building-sized treatment system, which could, I believe, which could be maintained by a utility, could be properly regulated, properly serviced. It's when you leave stuff up to the homeowner that you start to run some major risks. So point-of-use filtration is a good idea. It's certainly a good idea in terms of water quantity. I mean, this whole water distribution system issue where you're losing 40, 50, even more % of the water is flowing out to the surrounding soils and into the wastewater collection ditches is frankly completely unsustainable. I think of that huge waste of water that's gone through the whole treatment train. You know, so we've added a lot of chemicals, we've added a lot of energy to treat that water, and very, very little of it is actually necessary for ingestion. So there are numerous ideas are out there as to whether perhaps we can supply a separate potable water system requiring far smaller volumes of water to be distributed, or whether it makes more sense to truck water to individual homeowners. That comes with its own suite of problems too. And then have separate grey water systems within the home. Lots of ideas are thrown around. A grey water system with an individual treatment system at the house level. And some houses have that. Great idea if you're extraordinarily wealthy. But you know, the expense is really it's really a question of the expense and the maintenance issue.
How comfortable do you feel about the quality and the safety of bottled water?
Well, you know, I've done work in Mexico where I've actually seen them fill up the bottles from the hotel tap. So I'm not all that comfortable with bottled water in some of the places that I've traveled to. The problem in this country is it's regulated essentially by a different agency, in that the FDA, Food and Drug Administration, regulates bottled water and does not regulate it to the same extent that our municipal water is regulated. The Environmental Protection Agency regulates our municipal water and has a number of monitoring requirements, has a minimum disinfection limits, etc., and has constant monitoring for the presence of indicators of fecal contamination. The bottled water industry is essentially regulated by itself. So it really depends from company to company. I think most of us probably are no safer drinking bottled water than we are drinking municipal water in this country. I mean, that's primarily because we do disinfect to a fairly high level, and whenever we see an infringement, we just add more chlorine. Now, we're safer perhaps from pathogens. The whole other issue is whether we're consuming disinfection byproducts in that process. So because of the way it's regulated, the bottled water concerns me. Again, it's on a company-by-company basis. There is a lot of discussion out there at the moment that there are chemicals that leach from the bottles themselves. Some of those chemicals may be endocrine-disrupting chemicals. The science is rather poor on that area at the moment.
Morris briefly talked about the prospect of ozone replacing chlorination to purify water, and you touched upon it in terms of Russia. Is there anything you can add about ozonation, is that how you say it, to pure water?
Sure. Yeah. Ozonation is actually a great alternative as the first step in treatment because it sort of reduces color, reduces odor, reduces taste problems. If there's bromine, naturally occurring bromine in the water, it does form bromates, which are highly carcinogenic. So there is some risk of toxic disinfection byproducts with ozonation. It's more expensive, and it requires a higher degree of maintenance and training, but it's a much better idea than a pre-chlorination step. With water treatment, when you first add chlorine to a source water, particularly if there's high levels of organic material in that water, it rapidly combines with that organic material to form this wide range of what we consider to be toxic disinfection byproducts. So if you can reduce the precursors to these products, that's the organics in the water, and you can form fewer of those products by using ozonation, then you're much better off. Now, the problem with ozonation is that it doesn't leave any residual in the distribution system. So if you've got a leaky system, a sieve, that's distributing all your water, and you get wastewater flowing back siphoning into that distribution system, there's no protection if you just use ozonation. So what a lot of treatment plants have gone to is they have a pre-ozonation step, they then precipitate out, they use a coagulant to precipitate out all the particulate material, hopefully most of the microorganisms. They then filter, and they then do a post-chlorination step. They hope that by that time a lot of the organics will have been removed by precipitation and coagulation, and they'll form fewer disinfection byproducts. But they put that secondary post-chlorination step in to try and retain a very, very small residual at the tap, so that all the way through that distribution system there's some disinfection power in the drinking water supply. There's some bad sides to that too, in that there are a number of pathogens that, including Cryptosporidium, the one I showed you there, that are highly resistant to chlorine. So there's still some organisms that once they contaminate the drinking water, there's really no level of protection that we can supply except for point-of-use filtration.
Hi, Tim. I'd like to go back to your discussion of the developing world and safe water practices, and you mentioned that lack of education is a big contributor to health outcomes. I couldn't agree more. And first and foremost, I'm glad we have people like you out there that like to play with germs and worms, because some of us like the human behavior side and the education piece. When thinking about tailoring education for safe drinking water in the developing world, we have to stop and consider what is culturally tuned, and you mentioned that. Some of the latest research is suggesting that we provide this education and people have knowledge, especially in urban communities where there is schooling, there is knowledge, but that knowledge doesn't translate into attitude and practice towards drinking water. So I wondered if you had a comment about that.
Approaches to education?
Yeah.
In developing countries? I think we've been going about it completely the wrong way, of course. Having workshops run by people like me in developing countries is a totally useless way to convey the information. The other area of discussion I've had with the candidates for chair of the art department is how we could collaborate to sort of use the arts, use theater, use different approaches to conveying educational messages about hygiene and
Community-based,
sanitation.
yeah.
So, my feeling is that you've got to engage the community, and the community are the ones that have to teach each other. External people going in and trying to help don't are really pretty ineffective because they end up going away. They take their resources away. We try to, in Russia we try to do this. In Chernobyl, that's not a developing country. It's a transition economy. But we introduced a lot of expensive equipment. We trained people to monitor for cryptosporidium and a whole range of other pathogens. As soon as the World Bank funding finished, all that equipment was either sold on the black market or stuffed in the back of a cupboard, and everyone went back to their original practices. Now that's a sort of fairly extreme case. But if we can have a community-based participatory approach to any kind of educational activity, that's going to be far, far more effective.
The problem of clean water supply is a problem of the commons, if we want to go back to Garrett Hardin's sort of classic analogy about sort of sharing natural resources. And one of the warning notes that he offers at the very beginning of that essay is about the problem of no technology problem solutions, if I'm getting that phrase right, and the possibility that we may place too much faith in our ability to simply use technology to fix this sort of series of problems that we have around this particular issue. So I'm wondering if that's part of the discussion for any of the scientists who are working with this problem, that we might hit a tipping point, not just with sort of managing waste, but specifically with regard to chemicals in our water supply. And then a related question is about examples that you might know of communities that have actually sort of drastically turned around the quality of their water supply, whether it's because of sort of pollution from factories or sewage problems, et cetera.
The problem of too much technology or of too much advanced technology, in a way the second part of your question is easier. No, I know of no communities that have completely turned around their ability to supply clean drinking water to the public, to the community, including Boston and New York, Washington, D.C. In fact, they are some of the worst examples, and don't quote me on that. But there are problems in every municipality that relies on distribution of water in the way we're currently doing it, and we don't really have a high technology solution. Now, in terms of using nanofiltration, these technologies show tremendous hope for the future, but at the same time, we don't know what sort of risks will sort of result from essentially focusing entirely on cleaning up our drinking water supply. Maybe that'll take away the focus from treating our wastewater that could have huge ecological consequences. So, our problem is we don't have an ecosystem approach to treating drinking water. We don't look at that whole hydrologic cycle and understand that the water and the air is connected, whether it's groundwater, surface water, the ocean, the atmosphere. It's all connected, and so if we address water pollution, we need to also address air pollution. We will continue to develop these technologies. I don't know that any will eventually be the ideal example. Desalination, which is a fairly advanced technology, it's being used increasingly on the West Coast for cities like Los Angeles that have supplemented their drinking water supply with desalination. Obviously, in the Arab Emirates, they use desalination. That, in turn, creates a lot of waste. When you remove salt from seawater, you have the salt to dispose of, but you also have a lot of toxic chemicals in that salt material, too. So every technology seems to have a problem. The big focus amongst the NIH at the moment is nanoparticle pollution. So as we develop nanofiltration technologies, as we start using nanoparticles, we actually have really no idea what the environmental health consequences are to exposure to those particles we're generating by creating those technologies. So no easy answer for you. We're going to continue developing them, I'm sure. Whether it's a good idea or whether we should always look for low technology options. I tend to stay away a little bit from the technology debate because I know it's going to go on whatever I say, and because I focus much of my work in developing countries that are never going to be looking at nanofiltration technologies. What excites me tremendously at the moment is some work that a colleague of mine, Rita Colwell, has done. She was director of the National Science Foundation, which has shown that if you filter your water through a couple of layers of sari cloth, you can reduce cholera deaths by 50%. To me, that's fabulous. And that's the kind of intervention that makes sense. But even that kind of intervention requires the community context, requires training people within that community to make sure that the women in particular continue to do SARI filtration and don't sort of do it as a once-off because some Western person told them they should do that. Dr. Ribich?
Actually, I was going to ask you about Rita Caldwell's work because I learned of that when she was our graduation speaker last June, and I thought it was fascinating. And really, there are thousands of lives that are attributable to that have been saved, according to some of the stories that she was telling me. And could you just explain what does it do? What is it able to do that makes the cholera?
Well, that beautiful picture of cholera rising from the ocean was actually, Rita was part of that article that the picture was developed for. This bacteria seems to associate with a particular component of the phytoplankton, something called a copepod. And some of you may know what a copepod is, some may not. It's a tiny crustacean. But the bacteria is associated with the outside of the copepods and appears to grow on these copepods. And because it's associated with them, when SARI filtration is done, the filter material is thick enough, the weave or should I say the weave is fine enough that it takes out a lot of the copepods and a lot of particulate material too. And people who study cholera, Vibrio cholerae, have shown that it will associate with a lot of different particles. So if you remove the particles in drinking water, or many of those particles, you reduce the infectious dose in that water sample. So it's a very simple mechanical reduction process. Any cloth could be used. It doesn't have to be SARI material. Just in Bangladesh, that's a little more convenient than, say, my jacket or something of that nature.
I just was going to ask you to comment on home distillation units. Do you encounter the same problems with those that you would filtration units pertaining to, the maintenance and changing out the filters? And I was just curious pertaining to the education piece of it, if you happen to have Michael Moore's phone number.
Well, I don't have Michael Moore's phone number. Well, I sort of enjoyed some of his movies. In terms of home distillation, the problem with distillation is you really need to add back some elements to, improve the taste of the product, and from simple health reasons. By distillation, you're removing all the good elements as well as the bad elements. I would say that rather than having a home distillation unit, I would just boil your water, particularly if you consider yourself susceptible to any particular infectious agents. And this is the advice that I hope most medical doctors and osteopathic doctors would give to patients with compromised immunities to boil their water. Don't drink the tap water. Don't drink bottled water. Just bringing water to a boil will so dramatically decrease the level of infectious agents in that water sample that the likelihood of infection drops to, it's never zero, but it comes close. Whereas distillation is going to be expensive, it's going to be energy intensive, and it's not going to provide a particularly healthy product in terms of the elements left in that water sample.
Tim, I was wondering if we could connect it back to the global part of the program. And years ago, I used to work for a scientific organization, and we set up a marine reserve. And I suggested that out of the 10 scholarships or funding opportunities that they were setting up, that 1 or 2 be for an artist or a musician at this site. And they looked at me crazy. And it was for the reason that you described earlier, was that when you're in different cultures, you can inform people all you want with scientific data. But if they're not inspired, they're not going to change. And so how can that happen more often? In other words, how do we open up these areas of knowledge that we have in universities and that we are talking about tonight to make them work together better?
You know, on an international level, I'd say we were a bit behind in that area. I think Jennifer could probably speak well to that very topic. But in the US, we are seeing what I think is a very healthy trend towards community participation, with a number of initiatives from the National Institutes for Health looking for community-based participatory research, which includes all sectors of a community, including the artistic side of that community, everybody who can, on health topics, everyone who can potentially contribute to the healthy environment, the healthy lifestyle. In Europe, in the UK in particular, there's a big move now within health to focus on healthy lifestyles. My colleague at the Peninsula Medical School talks about the blue gym. People living next to the ocean are now being encouraged through the medical school to participate in sports related to the coastal environment, including art. And of course, you know, Maine would be a perfect place to have sort of that kind of art therapy integrated into all our health programs. On the international scale, I've actually been, because we do this with our Native American communities in Montana, we focus on participation directly with the communities. We always start our meetings with a storyteller, a prayer and a storyteller, in fact, from the local tribe, whichever tribe it is we're working with. And it really sets the stage for some wonderful discussions. Of course, we have our discussions, we tend to have our discussions in a talking circle, which is a lot better way to convey information to people than just having me stand at the front and talk to you. There may be a few too many people in this audience to form a talking circle. But if you've never done it, it really is a wonderful form of communication. I've been, on my trips to China and India, I talk about using a community participatory approach and how we can involve different factions within the community in conveying information such as hygiene and sanitation. But I think we're some way away from getting the major funding agencies to recognize that this is a valuable step forward. And some of it has come out of early World Bank publications, the need to engage communities and engage different disciplines. But Jennifer, you may know some more sounding examples of where that's happening. Is that happening in Ghana?
Well, I think that what's trying to happen is engaging the community health worker, providing the education for them and having that be translated through the communities. The community health worker, in my opinion, in the developing world is the critical liaison for health outcomes, because health professionals don't exist at the number. So training community health workers to be able to teach the knowledge that translates to attitudes and practice is extremely important.
It is, but we still have a long way to go in terms of involving the artists in the community. But I think that would be the way forward.
Tim.
Thank you. There was one thing that kept bothering me throughout the whole book. Robert Morris didn't talk about poverty. And tonight when you talked, most of the regions that you mentioned were the most poor regions. So talking about education, about fresh water and clean water, it's more about changing their whole environment and working towards eradicating poverty, which eventually will reflect on changing attitude towards water. And
to some extent, I agree with you there. The issue, though, is that has education really put us in this country in a better position in relation to water? And I don't think, obviously we don't have anywhere close to the same levels of waterborne disease. But, we really did get a wake-up call with Milwaukee, 400,000 people getting sick. And I've, being in this business, I've been very surprised that we haven't seen outbreaks of that scale in this country, given the condition of our water treatment systems, treatment and distribution and the quality of our source waters. So I think we've got a long way to go, and for us, it's actually we're disconnected. We're sort of protected, we've been falsely protected, I think, by our technologies from the reality of our need for access and our use of this resource. So we completely take it for granted that we can have a 10-minute, incredibly all-engulfing shower every morning, and that's become a way of life here. It's not a way of life in many developing countries, where you're right. I mean, the full burden of disease in the cities in India where I've worked is a poverty issue as much as it is a water quality issue. And with resources, they could be supplied with better water, perhaps. But you've got there's such a population issue, too. And we're able to have clean water here because we've kept our population to a much lower level, and we've done that in some ways by exploiting these other more developing countries. So there are many, many, many issues involved. There are different trade aspects to why developing countries face a very different burden of disease than we do here. Robert doesn't talk about developing countries because I think he really wanted to focus in that book about the cholera story and how it informed water treatment, our understanding of waterborne pathogens, and where we are today in the US. What people like Robert and myself feel is out there is this aspect of this risk that we've not protected ourselves from contaminated water, and that these are crises waiting, disasters waiting to happen. And I have no idea why there was not a huge outbreak of waterborne disease after Katrina. Everybody in water microbiology assumed there would be, and we were very, very lucky. The other huge disaster, major disaster, of course, the 2004 December tsunami that hit South Asia. That, for many of us, was going to initiate pandemic disease worldwide. It didn't because for a start, the initial catastrophe resulted in huge mortality. But after that mortality event, most of the water was salty, so it wasn't drunk, and particularly the Australians, actually, and other aid groups moved in very, very rapidly. The response to the tsunami outbreak was extraordinarily rapid. We're arguing that if we can have that kind of response to these major disasters, then we can intervene in time to prevent public health emergencies, major epidemic and pandemic diseases. In many countries, we don't see that kind of response. We had major flooding events in Africa have resulted in more cholera epidemics, but huge epidemics of other diseases too. What we're seeing is a trend in new disease emergence, changes in virulence patterns of different diseases. We've been all sort of terrified about avian flu over the past year or two. It hasn't happened here yet. We've got swine flu. That's bad enough. That's a serious human health risk. Avian flu was transmitted person to person. We'd have another 1918 flu epidemic, pandemic, worldwide. There's no real reason for that not to happen. In other words, the whole argument here is our infrastructure is not in place here, and it's not in place in developed countries either, to protect us against infectious disease risk, whether it be waterborne or otherwise. I don't know if I exactly answered your question there.
Just to confirm what you're saying, it seems to me that in no state that I'm aware of is it required to report gastrointestinal diseases that occur. Many patients don't go to physicians for the treatment, and physicians are not required to report to any state public health agency the existence of a gastrointestinal disease. It only reaches the attention of public health officials when it becomes an epidemic. So we have no way of knowing what kind of background environment we may be seeing in this country for chronic endemic, subacute examples of gastrointestinal diseases that are waterborne in their origin.
I think that's another excellent point, that we do have, we suspect we have a high level of infections from contaminated water and contaminated food too in this country that never get reported. And this underreporting is one of the reasons why when we do work in India and increasingly now on Montana's reservations and elsewhere, we're looking at community responses to questionnaire data about how often infectious disease events have occurred. which in itself is inaccurate. But if you look at the work from Hyderabad that I showed there briefly, we compared that to hospital incidence data, the reported data, and for some of those diseases, the community incidence is 400-fold the hospital incidence data. Now, unfortunately, policy decisions are made on hospital incidence data, official databases that come nowhere close to reflecting actual incidence of disease, which is why, burden of disease figures are literally meaningless. We actually think that water in this country is probably causing a huge number of low-level infections annually. We just have no way to quantify it. And even if you do go to a physician, the chances of a diagnostic test being ordered are relatively small. And even if a test is ordered and the pathogen is diagnosed, for most of the gastrointestinal infections, they're not reportable.
I'm presuming to ask this question on behalf of my friend Amy there. Do you think water could be a catalyst for peacemaking in the Middle East?
Well, it hasn't been so far. It's been a cause of international conflict, but I would hope so, Anwar, or whoever actually asked the question. I would love to think it could be, if we don't deal with the potential conflicts that are going to occur over water. And many people have said this since the 1980s, that water is going to be the next cause of international conflicts, more so than oil. Ismail Serageldin was probably the first person to state that from the World Bank. You'll hear a lot of people crediting that statement to themselves in subsequent years, but it's been around for a while, and it's a reality. I mean, it's happened already. I think we have to get to grips with the water shortage issue and the fact there are such extraordinary disparities between neighborhoods and between countries. I don't know how we do that. I think that very much is part of the Palestine-Israel debate in particular, but it occurs in many, many countries worldwide. So I have no easy answer for you there.
A question about the RLC. I read recently that they have reversed the destructive process there, that the RLC seems to be coming back in Kazakhstan. And of course, this is one of the worst stories probably in water anywhere in the world, where in order to grow cotton to help the economy, they depleted almost, 70–80% of the RLC. And so it diminished to almost just a fraction of what it was. But I read recently in some of the papers that apparently the sea is coming back. Was this just because the Kazakhstan government decided not to grow cotton in that area? Or do you know what the circumstances were and whether this is something that could maybe, if it was a process, a government decision, or just what it was, if it's something that could be somehow spread to other places where serious devastation has taken place?
I was following the Aral Sea story up through the early 2000s. I hadn't read that it was coming back, although I vaguely recollect something to that effect. And
in the Times a couple of days ago.
Yeah, I missed out on that. It could be a model for other places. I mean, the problem, or one of the problems with the Aral, with so much water diverted for the cotton, as you so rightly say, the groundwater supplies around the sea have also been dramatically depleted and very highly contaminated with toxic chemicals, particularly with pesticides and insecticides that are actually were creating mass poisonings of people in communities surrounding the Aral Sea. And of course, trade is dramatically affected with the depletion of the waters. Whether it's a good model, without knowing more about the political reasons behind its return, or the return of the water to the sea, which is obviously a very good thing. I mean, the depletion of a sea of that size, to the extent that it was depleted, has got to have a lot of ecological impacts throughout that region. And so, it's going to be an improvement. Whether it will prevent eventual desertification of the whole area, I don't know. I'd have to look a little more closely. So they're no longer growing the cotton crops, to your knowledge? Or are they finding another source of irrigation water?
From what I read, apparently Uzbekistan is going to continue cotton. And so a large portion that depends on water that flows through Uzbekistan is not going to come into the sea. So some parts of the sea are not going to grow, but other parts, already the water is coming back to where the dry dock ships were. And people are catching fish, freshwater fish, and the saltwater fish that were put in, the flounder, are dying, and the freshwater fish are growing again. So, but I think it was partly because of a decision to not to grow cotton there. But I don't know, really, and I wondered if you did. No,
I'm sorry, I'm afraid I don't, but I plan to look into that one. That's a very interesting and positive outcome from an area that was utterly devastated.
You touched several times upon the issue of infrastructure and how I think at one point you used the phrase failed infrastructure. And I was wondering if I could kind of get your opinion on what you think the most critical needs are at this point in terms of addressing those infrastructure problems. Is it, right now, should the focus be on replacing, the old pipes that are underneath all the cities, or is it that we need more filtration plants, or is there a critical need right now, or is it kind of at the point where, everything is just so, out of control and there's so many things that need to be done all at once? I guess, do you think there's a...
I'd stay with my original argument that I think Bob Morris would agree with about having this multi-barrier approach to protect human health in this country. It doesn't speak to the capacity or the water quantity issue, unfortunately, and that's the most important issue is to protect the water source. Obviously, if we're putting raw sewage into our water supplies, like the Ohio River or any surface waters, or the groundwater too, then we've got to expend an awful lot of money and energy to clean it up. So protecting the water source is number one, effective filtration and disinfection is number two, and number three is the distribution system. And all three of those, you need to focus on all three, because each one will make the other just that little bit more efficient. The issue is different in developing countries, where more low-cost interventions can obviously have a fairly dramatic health impact on populations that, as this lady described, are really suffering from so many different environmental struggles, including their socioeconomic status, which means they have no access to any of the technologies that we talk about in this country. So I wouldn't prioritize one over the other. There's absolutely no point in having expensive nanofiltration technologies if you're going to put that water out into a leaking sieve. I'd say we get away with it at the moment just by pushing that water through it at tremendous pressure. But at some point, the leaking sieve explodes from the pressure. Now, I was on the Cambridge Water Board for a number of years when I lived in the Boston area. And their distribution system was hugely problematic. They were replacing sections of it as fast as they possibly could, which was every time the system would fail and a pipe would break. And you'd see the road up, and you'd look at the pipe, and rust and water everywhere. And that's just what you can see. The rest of the system is not much better throughout the whole distribution. They were able, going full speed ahead, to replace 5 miles per year. They estimated at the time it would take 90 years to replace the distribution system. And the pipes can fail, if the water's acidic, in 20 years or less. So as I say, you've got to look at all three factions. Cleaning that distribution system was impossible, because they do something called pigging, where you have this big round wire-covered brush that you push through a distribution system with a lot of water pressure behind it. They didn't dare do that with Cambridge Water System, because it literally would have collapsed. Did I answer all your question there? or did I just speak to the problems?
I just wanted a cultural story just to show how important water was embedded in different cultures. In the Mediterranean countries, if you give somebody the evil eye, the source of that is that if you give them the evil eye, you're actually causing them to dry up so that they become infertile. And in order to counter the evil eye, you're supposed to spit 3 times or have a charm that's a fish in order to bring the water back into the circulation.
So another example of how water is so tied up in culture or cultural practices. Thank you.
I have. Oh. Hello? Okay.
You're going to correct me on what I said about India, aren't you?
No. Hence the last question, I suppose. Now, I've been thinking what to ask you about your work in India, but what I came up with is the following. What is your understanding of Indian government's role in the modernization of the infrastructure? Obviously, there's huge incentive for attracting global businesses, and one such example will be tannery industry. And I say this from my personal experience. When I was visiting in Kolkata last year, I went to a spot where there's a huge tannery industry funded by the government with a third-party intervention from China and Malaysia. And all the pollutants are directly going into dry riverbed, and which is then carrying out to the mouth of the Ganges in the Delta area. And my question nearby was that, is this water getting treated? And everybody said, well, we think so, but we don't know for sure. And the water, I mean, I visited this area and it was black. And right outside that are all the poor community and the villages. So in here is an example of how government can be motivated by developing economically, but at the same time not paying attention to the environmental issues such as water quality. So I wanted to ask you whether you have seen any motivation from the Indian government to do anything about these kinds of rapid development.
Only insofar that we did get some movement in Hyderabad towards putting in wastewater collection systems, increasing chlorination in their distribution system, and repairing some of the aging piping in that distribution system. But the only reason we could do that was because our doctoral student, Jatish Mohanty, who I referenced on that data slide with the infectious diseases, was part of the Indian government. And he's now running, I believe, for governor of Andhra Pradesh. I wish him a lot of luck. He's somebody that is really motivated by helping develop public works. But unless you've got the decision makers involved, then I think moving forward is extraordinarily difficult. And that's, again, what we've tried to do in Varanasi, is give that information primarily to this foundation, the Sankat Mochan Foundation, that works with state government there as well, to try and provide evidence to upgrade or to put in place wastewater treatment. Because in the case of the Ganges River, it really is the fact that you've got so many major cities down the length of the Ganges, so many sources of untreated pollution, that if people are consuming that water, mitigating risk is going to be virtually impossible given the cultural and religious activities that go on in the Ganges.
Any more questions? If not, I want to thank Tim for tremendous, thank you so much for a wonderful lecture. And we have, Tim, we have some red water waiting for you outside.
Splendid. I can throw this one away?
I just want to let you know, for those who are coming here for the first time, we have in attendance here students from UNE, and some of them asked questions today, so I was very proud of them for having read the book and asked the very insightful questions on the topic. We have students from USM, we have faculty members from UNE and members of the public from various professions, and we have one member here from the legislature of Romania. So keep looking at the website. We have all kinds of information. The next We are lucky enough to have tonight with us the next speaker lecturer, Steve Rose, sitting right there in front. He will be talking about unnatural causes inequity in the distribution of wealth and health. We will continue our discussion of inequalities and inequities in its various guises. Now it's time for a wonderful reception, and the food is waiting outside. Thank you so much.